Thank you, Laura. I'd like to extend a special welcome to all of our colleagues from Lilly and also our special guests from Indiana, special guests from Apple. As we look forward to the next with the IRC conference, to me it's very exciting, and it's an interesting time in which we are. As we think about what we have done with information technology, the best is in front of us. And last week we had a meeting where worldwide seniors came together, back at the 80s, and talked about things we accomplished and the issues we'd addressed. And we looked forward to the 90s and looked at the challenges that face us. And as Mr. Wood was summarizing, Mr. Wood is chairman of the company, was summarizing the issues that face us in the 90s. One of the key things that he focused on was using information technology in innovative ways to really give us competitive advantage. And I think that's an exciting challenge for a lot of us in the room as we think about the things that are going on right now. And while, as you will see tomorrow when we have a segment called Show Business, where colleagues in the company will share what they're doing with information technology, we have so much more ahead of us in terms of the way we can work and collaborate together and use these phenomenal tools to really transform business. For us to be successful in the 90s, and as we look at our vision for Enterprise 2000, transformation is the bottom. As you heard Laura comment on some of the key phrases in our vision, extending capability, promoting global collaboration, natural access to people. That's our dream. And we think that all of you are going to play a significant part in making that within Eli Lilly and Company. I'm very pleased to introduce our guest speaker this morning, Dr. Alan Kay. Alan has been a leader in terms of computer technology, thinking about the future, where it's going to lead. And he's already participated in many important things that we're using day by day. Earned his electrical engineering, his PhD in computer science at the University of Utah, and then at Xerox Palo Alto Research Center, where they worked on some very unique and exciting concepts in the 70s. A lot of those we see today in the Macintosh that many of us use. He then went to Atari, where he was a vice president and chief scientist for that company, and has subsequently joined Apple, where he's an Apple Fellow. And he's one of the key people at Apple who dream about the future and what's going to happen. And as we look forward to his comments on the third computer revolution, I'm sure he's going to provide us some exciting kinds of inputs. So please join with me in welcoming Alan Kay.
Well, thanks for inviting me here. It's wonderful to discover there's actually a non-stop plane between Los Angeles and Indianapolis, which I took advantage of. when we think about the future, most people think about the future that flows out of the past in a way that seems fairly natural. There's a progression of events that we can understand. Now, it's been since the future became a concept back around the time of the Greeks, when Heraclitus said something that is constant change. That's something we often say today. That was a new idea back then, because for most of humanity, in fact, for most of the people even in the world today, they live and die in pretty much the same world. Not a lot of change still for half of the Earth's population. Now, something happened 90 years ago that made everything different. McLuhan said about the 20th century that it was a century in which change changed. And this constant redefinition of change is something we haven't been able to cope with yet. It's something that is much more like trying to predict a thunderstorm, something that obeys the laws of physics, does come out of the past and the present somehow, but is nonetheless very surprising when it doesn't happen. I remember when I was a systems programmer at the National Center for Atmospheric Research in the 60s, we were doing these huge atmosphere weather simulations on the supercomputer. I once asked a meteorologist what they're going to be like today, and to my great surprise, I went and looked out the window. And I said, "What are you doing that for? You know, we're millions of dollars in the weather. Why can't we do simulation?" And he said, "Alan, you don't understand. The atmosphere is so unstable that if a farmer had to go out and plow a field, that would be enough to set up an instability that could be the start of a thunderstorm. And even a single oak tree being in one place and not another can set off the instability." And I was just looking outside to see if any clouds were forming from any of these instabilities. And the simulation models we were using used 9,000 data for the entire northern hemisphere of the Earth. So all of these causers of thunderstorms, trees, and plowed fields didn't show up in this simulation. So that's sort of where we are, that the future we'd most likely in this century is like the thunderstorm, because that's the biggest crisis. People are all predicting against, in fact, many of the things that take us by storm. I have a collection of them made over the years. One of the minutes from an 1995 board meeting in the Union, the telegraph company, in which they decisively turned investment in telephone. And what sticks in my mind from those minutes is one of the board members, no sane person would ever business through such a contrivance. And there's actually for it because they had recently come up with a printing. Remember telegrams? They strips of white paper and pasted on it. Came by and delivered. They'd come up with a printing telegraph that they now could have of every business transaction. And would much rather do it that way because they could keep track. This is like the reasoning for electronic today. Keep of every transaction, so people will not as soon as something better, but in fact they did. Another great prediction was by Lord Hallam, who was the head of the Ministry of War in Great Britain. In 1907, he said the heavier-than-air aircraft will never fly. That was pretty good because that was 4 it had flown. These are the kind of predictions that government people wait until the thing has really happened and then predict against it. So to get a handle on this stuff, and particularly with regard to information technology, which has related 400 years of what has happened with the book, and we have to have ways of getting it that don't have to do with extreme. In the 70s, when we were trying to do personal computing, people kept on saying, well, we can do that on the mainframe. And this problem was that they couldn't imagine computing outside of the computing that they were actually doing. And this we see quite a bit. When Edison invented the movie camera in 1895, there was about a 20-year lag between the invention of the camera and somebody's decision to first move it. The camera was thought, in fact, there were ads back then that said, everybody has a third row front center seat, and the Barons now come to Cincinnati. The idea is the camera is a stand-in for the perfect place to sit in the audience, and what it was doing was recording events that were basically theatrical. And nobody questioned that because that's thought of as being a replacement from the theater. You went to see it in things that were like theaters. Until D.W. Griffith came along and realized, well, you could move the camera, you could do tracking shots, you can do montages, you could do quick cutting, you could do all on film language. Today, 20 years before I realized that you could actually do that. And the same happened with the mainframe and the advent of computing. One important idea is that when a new medium comes along, it takes its initial content from the old media, and this comforts people to a certain extent. And then surprise comes along because the thing it's really for emerges some years later, and then everything changes. That has happened many, many times in history. So what I'd like to do is to talk about the revolutions. So the first revolution is not the invention of the computer, because that was a revolution in information representation and processing. So it's in the same level of the invention of the printing press. But to talk about the revolutions within computerdom itself, and just to give you an idea of how this started in a kind of innocuous way, let's take a trip back into the past for a bit and look at a scene. I put lights down for this, and here's a thing that could be in people's office in Lily's today. Not everybody at Lilly has a mouse, and not everybody at Lilly looks at a 19-inch high-resolution black-on-white television screen, but some people do. And for those people, in fact, for all of the people, might be interested to realize that the picture was taken in 1966. This picture is 24 years old. Sitting there is Douglas Engelbart, inventor of the mouse, and I think of as the father of desktop computing, what we call personal computing. And here's what his system was able to do, in part. And what I'm going to show you now is a demonstration in front of 3,000 people in 1968, 22 years ago.
So I can say, I'd like to go to produce, but I'd like to go to produce, they get big. I'd like to say one branch, and look just that low, and I see it. Oh, I can say, I'd like to see one line only. I can see it. But there's another thing I can do. There's a root I have here. So here, I'm afraid I'll need a different picture of the view. So here's what I drew with a picture drawing capability here. It's a slight map if I start from work, and here's the route I seem to have to go to pick up all the materials. And that's my plan for getting home tonight. But I can say, the line am I supposed to pick up there? I can just point to that, and oh, I see, overdue books and all. Well, there was a statement there with that name on it. Go back. What am I supposed to pick up at the drugstore? I see, very interesting. All right. Market can do things if I want to just say interchange produce materials. Bingo. And they're all numbered rightly if I care to look. Changing them very quickly. Hands are going to get interchanged with produce. They do three numbered.
So that was 22 years ago, and since it's been so long, we can confidently predict that something like this will be in most people's offices by the year 2000. So here's an example. Engelbart was thinking about non-traditional uses of computers around 1962, and it was part of a larger effort that said batch processing stinks. There must be a way to have a closer relationship with the computer, and as Jack Licklider said, to have the computer a kind of complementary partner. It doesn't have to be like a human, but it wants to be a complement, an amplifier to the kinds of things that we're trying to do. And Engelbart's project was one of the responses to this, and he had to invent a lot of basic technology. The first existing hypertext system. There's another tape that I don't have with me that shows face-to-face conferencing through this system, all done back in the 60s. And my response to this was to design this machine. This is the first personal computer I did. This is around 1967. Was a desktop machine for very special desks, namely those made out of steel. So it weighed about 350 pounds. It had a fan, it was 747. So it's full of those little black boxes that hold the silicon in the machines, which you have about 50 in your IBM PC or Mac. There are about 700 in this machine, because the integrated circuit was just coming in. The integrated circuit is the forcing function for this kind of technology. You've taken some of the ideas like Engelbart had, which are implemented on a time-sharing system, and discover quickly that when you want to interact directly, it's almost impossible to do it on time-sharing because you can't guarantee the cycles that each user needs when the user needs them. So you have these famous lags that you get from time-sharing and a reduction in the kinds of expectations you have from the system, and really don't have something like interaction. You have something that's a little more like negotiation. You do something and then you wait to see if you're going to do something, and so forth. So this personal computer was the first computer years earlier, but it was the first one that had the name personal computer, and it was very much tool-like. Tools are physical things like levers and wheels. They're also mental things, language and math. All of them I think of gesture. The M word is manipulation, because even what we think of as being abstract is actually a concrete way of dealing with the abstract. Take all the abstractions, make them into concrete little symbols, and all of a sudden they're out here, look at them and move them. So all of these ways in the world are basically they're extensions of the body in a particular way. Now, while this was going on, some people were working on a very different way of dealing with the computer. Example of it. This was done at Rand Corporation. Economists are people which, if you lay them end to end in the world, they can reach a conclusion. And they said to people, yeah, we have to do some computing. None of us know how to type. Can't do anything about that. So here's what the RAND people did.
First, we erase the arrow, then move the connector out of the way so that we may draw a box in its place.
So it sees he wants, makes one for him. Now it's recognizing his handwriting.
The printing in the box is used as commentary only in this case. The box is slightly too large, so we may change its size.
That's where modern-day window control came from, literally.
Then draw a from the connector to attach an element to the box and draw a flow from it to scan. We then erase the flow arrow to the process area and move the box to a new position. This is to draw a new box.
Well, I had a chance to use the system for half an hour in 1968, and it felt completely different from the Engelbart system. Engelbart's system felt a little bit like you're doing a dangerous experiment in radioactive chemistry, where there's some 3 feet of lead you're and hoping nothing would go wrong. And in this system, it felt like you were sinking your hands right through the glass of the display and touching the information structures directly. This system felt intimate. And so I thought of what this system was doing was kind of more of an intimate relationship. This was me, whereas the Engelbart system, as a system, tool is something that you watch and you manipulate it. And this kind of system was something that was watching me, and it was more like I was managing it. I was sort of showing it more or less what I wanted it, and it was figuring out the rest and completing it. So I had a very different way of thinking about it. And so I made, in 1968, I made this cardboard model of what an intimate computer would look like. The dimensions were arrived at by a variety of means. One is that we quickly realized that portability means you have to be able to carry it too. 0.5 herniations per block is not portability. And this model we loaded up with BB shot to see how heavy you could make it before you didn't want to carry it around anymore. And we asked crazy questions like, what kind of a computer would it have to be so that you would do something so mundane as to put down your grocery list on it, carry it into market, and be willing to carry it out again with 2 bags of groceries. Now, let's how many people have a that looks like this right now? Can you hold it up? Well, then you don't have one like this. So most people have paper and pens and stuff on them, but so this is a different kind of thing than a desktop computer. And so now we're confronted by 3 different ways of thinking about things. The computerdom was going from batch processing to time sharing, changing the relationship of the user in a big way. The next big change was going from time sharing to personal desktop computers. Again, a huge change, particularly user interface, the new user interface of using windows and icons and stuff is well in. What we're looking here is a third revolution. These are not smaller desktop machines, but of course laptops right now are smaller desktops, run the software, because they're just imitating what came before, the way MS-DOS imitated the interaction that you did on the mainframe. So this early thing, we don't really realize that when you change the relationship of the user with the machine in a big way, what the person winds up doing and the kinds of software that gets built and used is very, very different. Now, if integrated circuits were the forcing function for the desktop machine, what's the forcing function for this machine? Well, it's networking. Networking? Yeah. These computers pervasively network. There will never be a time when the computer is talking to a network. To watch, they won't have an on-off switch. One of the ways of testing whether technology is intimate or not. Non-intimate technology has on-off switches. And the reason they can afford to have on-off switches is they aren't all that important. You use them, may use them every day, but they aren't in your life. As paper does not have an on-off switch, thank goodness. And they used to make some watches. Digital watches had LCD displays that used a lot of battery power. You had to press them in order to get them to light up. Remember those? The old Acrotrons? They didn't last. Because you don't want to go to that much trouble to find out what the time is. You want to find out the time as being part of your own environment, not something that's outside of your own environment. So the metaphor here is another way of extending humans, but not the tool way, what we call agents. And an agent is something that can take on our goals and carry them out on our behalf. So simple agents can manipulate tools for us. That's nice. We can take a nap while somebody else is wielding the screwdriver. And then agents can do something that tools don't do, and that is that they can deal with other agents. So once an agent has cloned our goals, they can spread that goal around. And in fact, we're part of just such a goal cloning setup right here in this room. Because as Lewis Mumford pointed out many years ago, most of the machines made by people for most of human history have had other humans as their moving parts. So you call them mega machines, and they were things as large as Egyptian civilization, small hunting parties, businesses, Boy Scout troops, whole panoply of things where a bunch of people get together and share a goal, work on it. And so the M word is management here. So a tool is something you look at and manipulate. An agent is something that looks at you and you manage it. And our belief is that just as we go from something like a control panel outside of human scale when time sharing to the desktop computer, so we found a tool metaphor for people. As we go to the intimate computer, where we're going to be connected with a pervasive network that stretches all over the globe and more than 1 trillion objects, that the whole metaphor of dealing with the computer and what it's attached to is going to change. And why do networks force agents? Well, when you have 1 trillion objects continually online, you're not going to spend a lot of time using SQL to try and find things. All current information retrieving tools over-retrieve, and when you're dipping into trillions of objects instead of a particular file where you happen to know the information is, you can't afford to try and do the retrievals yourself. Just as in the Library of Congress, where the card catalog is much larger than any library in Indianapolis, as an example. Library of Congress has some 85 million documents in it. The card catalog is larger than most hometown libraries. When you go in there, you don't use the card catalog. You actually are introduced to a person, and that person attempts to find out what you're interested in. That person is an expert at finding those kinds of things amongst all the different kinds of document collections. And so we think something much more like that is going to happen. So here's another way of thinking about these three revolutions. Institutional. Now we can make an analogy to books, and I will in just a second, but let's take a look at three of them. Like, where is it? Well, the mainframe's owned by the institution. Here's a computer that you can own if you want, Sometimes it's still owned by institutions because they're right in that borderline. We haven't decided it's quite as useful as a car yet. So only some people own their own machines. And then wherever you go, the intimate computer will go, small enough and continually connected. You don't have to be in any particular place in order to use the thing. Now, there's a nice parallel here with the history of books. The invention of writing is very much like the invention of the computer. It's a new way of representing information. And the first revolution in the invention of writing you can think of as the manuscript books that were copied by monks in the Middle Ages. It's hard for us to get a sense of the scale of things back then. One of the largest libraries in Europe at the end of the Middle Ages was the Vatican Library, as you might guess. The Vatican Library in the year 1400 had 392 books. Now, did a library look like it did today with books on the shelves? No. There's still an ancient library in Florence. You go into one of these things, each book had its own desk. They weren't in the wall, they were actually on a desk, open and chained to the desk, because these books were almost priceless. They took about 15 years to copy. So you went from desk to read a book. Now, if you look in one of these antique libraries like the one in Florence, nothing strikes me more than that this looks like a time-sharing bullpen. Right? It's like a room with 50 terminals in it. Too expensive for any one person to own. Now, when Gutenberg came along, he made books, but the books were the same size as the middle-aged manuscripts. Why? Because nobody knew what size a book should be. That's the size that books were. What did the fonts look like in Gutenberg's book? Well, they looked like script fonts that the monks wrote. They were 36-point type, 30 and 36-point type, half an inch high, big books. And their thought was that they would still be owned by institutions, but now cities could own them. So, huge advance with Gutenberg, but it didn't make it. How many people here have ever heard of Aldus? How many people here use a piece of software called Aldus PageMaker? Okay, Aldus's last name was not PageMaker. It would be great if it was. His last name was Manutius, and a printer that was born 2 years before the printing press was invented. So here is a guy whose entire life growing up in printed books, and when he was in his 30s, he decided a couple of very important things. One is that there should be lots of books. Bibles weren't enough, and so Aldus and his sons over the century printed some 40,000 different books in their lifetime. And they were one of the major sources for ideas of the Greeks and Romans, because they gathered up all the Greek and Roman writings they could find and published them as books. But Aldus did something that will always endear himself to me. He decided that books should be the size they are today. And I wonder if anybody here knows why Aldus decided books should be this size.
I know what I heard before.
Oh, okay. You heard me give the talk before. Yeah. Well, that's not fair. He decided they should be this size because that was the size that saddlebags were in Venice in the 1480s. Okay, so Aldus had come to, 30 years after the printing press, he'd come to a tremendous realization, and that is that books could now be lost. Think about what that means. Because books could now be lost, they can now be taken with, things could happen to them, and they had to be a different size, and that size change forced Aldus to become one of the first typographers. Because these script fonts did not shrink down very well, he started developing fonts based on Roman fonts and developed lowercase characters, and most of the fonts that we read from today, Aldus had a hand in designing. So he had to design the display now for doing these newly intimate books. So, important thing for us today is the thing that when you look back in history, that what happened between Gutenberg and Aldous, which is where we are today in computers, counted not a whit. Nothing that happened between Gutenberg and Aldous was significant, because all of the things that we think of as flowing from the book actually happened after Aldous had made it into an intimate thing that could now be lost. So we have to ask, what are computers going to be like when we can afford to lose our computers? Something that most of us would not countenance today. Now, if we jump into a pool with a Japanese watch on that costs $12.95, we say, that's too bad, but I'll go get another one. If we jump into a computer with our Mac or our IBM PC, we have a very different feeling about it, because all of a sudden we've ruined something that costs several dollars. We have to realize that the multiple thousands of dollars is not the right scale for something that is like a dynamic book. And so when we talk about things, one of the best ways of predicting the future is to try and figure out what paradigm you're in. So in the not actually too many years in the future, there was a paradigm shift in astronomy where went from most people believing that the sun went around the Earth, the Ptolemaic way of thinking about things, suddenly got turned around by Copernicus and Kepler and Newton into a heliocentric way of looking at things, and the world was never the same again. Never the same. On a book called The Structure of Scientific Revolutions, Thomas Kuhn pointed out that the reason most scientific revolutions take about 25 or 30 years to happen is that you have to wait for the old physicists to die off. Now, if this is happening to scientists who are supposed to be always open to new versions of the truth, but if scientists actually get imprinted like ducks on old versions and old worldviews and have to die off before new ideas can come along, then it's no wonder that we have the hardest time recognizing these paradigm shifts, even wanting to see that they're happening and adapting to them. Now, the problem we've had in computing science is that the technology is moving along in such a way that we've been able to recapitulate 400 years in the development of most technologies in just 40. And so we've gone from batch processing to time sharing. One of the funnier announcements that has been made in the last 30 years was when IBM announced that it had invented time sharing. That happened around 1970 or so, which is just about 10 years after it had been invented. But now it was real. Now it was time sharing with capital T and capital S. And actually, IBM had been against time sharing in many ways for years until it had actually come up with a version of its own. That's a perfect example of a company that has a vested interest in one particular technology, lagging behind, and then all of a sudden saying, oh, here it is. And of course, the personal computer companies like Apple have to be very careful, because if we think of ourselves as a desktop computer company, then we're in exactly the same place as IBM and DEC are for this new revolution that's coming along, which is quite different. And in fact, it's the kind of hardware revolution that the Japanese are much better at than we are, having to do with a combination of both highly dense silicon, artificial intelligence, and digital wireless communications. Communications is an interesting thing. One of the simpler ways of thinking about it is my friend Nicholas Negroponte of the Media Lab at MIT likes to say, he says, everything that is going through wires right now is going to go through the air, and everything that's going through the air right now is going to go through wires. So it's a complete inversion. In other words, television is going to be forced into fiber for various reasons, including hi-fi, and telephone, which now goes through wires, is going to be forced into the air because we can't afford to wait to get to a telephone for all the things that we need to get through it. Not just being able to talk to people when we want, as we do through cellular telephone, but we need to be able to exchange data in various ways, and so we must be able to do it wireless. So the sleeper technology in the network revolution in the next 10 years is wireless networking of various kinds. We are not in the U.S. Ahead in this because we're still conservatively trying to, we think improving what we're doing is making better wires and so forth. Very similar to the railroads in the 20s who thought improving what they were doing was to make faster locomotives and lay more track. So while they were looking like this, their competition had taken to the third dimension and was flying over them. No railroad in America ever invested in an airline company. It's interesting. A survey in the 20s would have shown them that there would be more track and more railroads, but they would never have asked the question of whether they'd still be in business in 50 years. Okay, and that's what these paradigm shifts do to you. Now, 10, 20 years from now, there'll still be mainframes. 10, 20 years from now, there'll still be desktop computers. 10, 20 years from now, there'll still be COBOL. Right? That's not the problem. The problem is what are the tools that are going to give you the leverage that you need? And those tools are not going to be the mainframe, they're not going to be the desktop computer, and they are certainly not going to be COBOL. So let's take a look at contrasting these three, we call them paradigms, after scientific revolutions. How do we measure performance? Well, in the mainframe, it's response time. There's a phrase called path length, which is the millions of instructions that you execute before you get a response back at the terminal. I once asked 3,000 Macintosh developers if they'd ever heard the phrase path length, and none of them had, because the issue on desktop computers is MIPS. Sort of like in the 50s, you know, those great old Dodges with 450 horsepower that you could lay a strip of rubber a block long. So particular, most of you here are not old enough to remember that. Wonderful. That was when gas was still 25 cents a gallon. You could, but that's not the issue, because the issue actually is going to be access. It's, can I find the resources I need? I'm going to be connected up to damn near everything in 10 years. But can I find what I need? I don't even know what its name is. A lot of things I need, I don't even know that they exist. They're actually analogous to the things I'm working on, not directly related. How am I going to find them? Once I find them and I get them shipped to me, what's the probability I'm going to be able to use them? I can barely use another application that I get for my personal computer at Egghead Software. What if somebody in Hindustan has done the perfect application for me, and it's delivered to me and it's certified that this is exactly what I want, and I can't sit down and use it? Pretty frustrating. Those are going to be the issues of the next 10 years. Kinds of data. You know, I thought these green and white listing papers had gone forever, and I saw one in my doctor's office the other day, and that caused me to look into his other state-of-the-art medical practices. Eventually changed my doctor. They're still around. Fonts and graphics on personal computers, on the Macintosh style of doing things, and all other media coming in this next revolution. And it doesn't mean just all other media on your machine, but because the next revolution is a network revolution, it means that we have to be able to retrieve all other media. And it doesn't mean just shipping film clips and stuff over the networks. It means that we have to be able to retrieve into the interior, because most retrievals are done by asking things about the content. So it implies that some of the work, for instance, being done by the Getty Foundation, I'm being able to retrieve pictures by talking about their contents, or even making a little sketch of a painting that you've seen 20 years ago and having the computer find all things that are like the sketch are implied here. How do we integrate information? Very painfully on the mainframe, usually done through files, sometimes with a relational database. I was shocked when I did this slide that I did not know what the actual penetration of relational databases was. I presumed it was like 90%. So I actually called up some friends of mine at the Gartner group and discovered that for the Fortune 1000 companies in the US, less than half of the company's information is in relational databases. And I presume that's more or less true of Lilly too. That is remarkable considering relational database was not a big improvement over flat files and is more than 20 years old. So that is a very, very slow adoption rate. On Macintosh-style computers, you can cut and paste from any application to any other application. And to the extent that things are object-oriented, the result will be compatible. In the future, instead of cutting and pasting pictures, the things that we see on the screen, what will be actually moving is the views of the application itself. So the application will actually still be active, but can be used as a component of any other application. And some of the operating systems that are just starting to happen now allow you to do, or at least start to do, things like this. How do you give commands? Remember and type. So one of the ways of thinking about it is, what is the job of the user interface? Well, the job of the user interface in this way of computing is sort of like a control panel of a nuclear reactor. You know, it's to give you access to function. There's all this function in there, and we'll map it into control keys and different screens and so forth. And it's not a bad way of doing it. It's used for other kinds of things. In this user interface, it's C and point, and the job of the user interface is not to provide access to function anymore, but to make the user aware of what the possibilities are. In other words, the user interface in the Macintosh style is a learning environment. Its job is, regardless of what you're trying to do, its job is to make you aware of the whole machine. And the result is about the average number of applications used by MS-DOS users, as an example, is about 2, and the average number of applications used by Macintosh users is about 7.5. And the reason is that you expect in this kind of user interface that the new application that you may have borrowed from somebody or may have gotten off the local AreaNet server, that you expect that the new application is going to be very much like the applications that you've already used. We look for a transference of something like 70 to 80% between applications of familiarity. So a person can do 70% of the operations from one application to another without having to open the manual. And most people never open the manuals, which actually is not great, because this is not a perfect interface. There are usually, unfortunately, things in the manuals that are worthwhile knowing. The interface doesn't make up for it. And in the Internet computer, because we're dealing with agents, it's going to be much more anthropomorphic. It's going to be gesture, like you saw. It's going to be speech in a variety of ways. It could be written English, it could be spoken English, but it's going to be much more casual. It's going to be something much more like advice. The feel of interaction feels like editing a line of text. Feels like layout on the Macintosh, and it feels like conducting on the Intimate computer, because what you're dealing with are active elements rather than passive ones. So I called the user interface that, with the overlapping windows and so forth, when I wrote my thesis, was called a reactive engine. It was designed to react to the kinds of things that you're doing, and the new user interface will be proactive. It will be actually doing things ahead of you, trying to anticipate the kinds of things that you'll need. How do you print? Big impact printing and enormous big laser printers now. Personal laser printers, and no printing in the Intimate thing. Now, people have been predicting this for years, and as people like to say in the newspapers, there's more paper now than there ever has been. So how can this prediction possibly be true? And here's the reason this is really going to happen. two things are going to happen over the next 10 years that are going to make printing a very low-yield operation. One of them is hypermedia. Not just having different kinds of media, but having the media interconnected in many different ways. That means that printing out any piece of hypermedia is going to destroy a lot of what's interesting about it. Hypermedia is designed to be dynamically dealt with. It doesn't lay out linearly in a very good way because it makes use of this idea that the computer always has more dimensions than your data. So if you have n-dimensional data space, the computer can give n+1 dimensions and bring all of the things to one place. Actually, if I had a pencil, I'd illustrate that, but I don't. And the other thing is that we're going to be rapidly going from data structures, which are passive representations, very much like the words in a book. We're going to be going from data structures to active simulations. People don't want just to see what happened in the corporation 3 months ago. They really would like to be dealing with a model of the company, like people do in a crude way with spreadsheets, a model that they can ask what-if questions of, to try different kinds of simulation and other kinds of gaming to try and figure out what they should do next. So both the multidimensional and the simulation aspects are absolutely antithetical to printing, and I believe that both of them are going to dominate to the place where we will not be as interested in printing, and the little machines with the page size displays that weigh less than 2 pounds will come along in just the nick of time so that we don't care whether we print or not. What we actually want is an active copy of that information on the machine itself that we can look at whenever we want. So I think all of the technologies are going to hit together just at the right time, and printing for most things will go away. Just as there are very few things besides university, we'll probably still print university diplomas, right? Because we still use vellum, and I guess most universities today don't even go to vellum or parchment anymore because it's so expensive. They probably use a Mac to do it. Cheat. So what kind of software? One-purpose custom application. Typical kind of thing that an Arthur Andersen does for a customer like Eli Lilly, or it could be a big billing system, it could be a chemical analysis system, it could be an airline's reservation system. On personal computers, we can run those kinds of things, but what we generally run on them are what are called generic tools. These are tools that are like frameworks. Desktop publishing systems, spreadsheets. They're frameworks that the end users do stuff that is dangerously like programming. Worries MIS people no end, because there are all of these end users out there subverting them. Some end user needs something, puts it into the MIS department, and gets back a friendly note saying, yes, we'll be glad to do this for you. We'll do it in COBOL on the mainframe, and you'll get it in about 1.5 years. So the user goes away, and a few months later they think, well, maybe I should try that in Excel. And they sit down and start hacking up something in Excel, and by the time the COBOL program line comes along 1.5 years later, the personal computer user has forgotten he even asked for it, because he's built some incredibly hairy kludge all by himself that does 90% of what he wants. So there are various ways of going. One of the things you could do is stamp out this kind of subversive activity by instituting thought police in the companies, so that only MIS COBOL programmers are allowed to write code. Or the other thing you could do is to say, well, users do have a tendency of trying to get on with it, and maybe what we should do is give them better tools. So this whole notion of end user programming was something that was born at Xerox PARC, was the idea of the end users are going to do stuff. Let's try and figure out safer frameworks for them to do this. We don't expect them to be architects, but they sure are going to build doghouses of various kinds for themselves. So let's see what kind of a doghouse we can let them build before they have to go and study architecture to do it. And this is even more so in the next 10 years, because we're going to go to active self-customizable components. I'm going to try and explain that a little bit in a couple of minutes. That will make it much, much easier for the end users to put together their own tools. So the languages change. COBOL is a data structure and procedure language like Fortran and Algol and Pascal. That's what we call in the biz weakly modular. One of the ways of thinking, in other words, is modules are things called data structures and things called procedures. And this is not a happy division of the computer stuff, because when you move a data structure from point A to point B and there's maybe 1,000 miles in between them, you have to write a lot of code to use that data structure when it comes to the other end. If you don't send the code along with it, and there's a rule in this kind of programming that you never send all of the code that it's needed, and when you change the representation of it, you never change all the procedures that knew the old representation. And so the result here is some lightning bolts. So you wind up with very large, fragile, spaghetti-like code with this way of doing things. Nonetheless, this is the dominant way of doing things. There are whole companies that make their living doing nothing but writing programs like this that seem to work. Now another, Alan, let's see if did I do a whole bunch of them like this? No. So ignore the one on the right. Take a look at this. Take a look at the center for a second. In object-oriented programming, what you do is, there are two things. One is you don't care how the data is represented. You just want to use it. So you can stick all of the state-specific stuff inside a thing called, a little cloud called an object. And the way you make it independent of its representation is that you put all the procedures that know what the actual representation is inside there too. You make a little package. When you send that package 1,000 miles, you only have to write a very little bit of code in order to use the object safely by sending messages to it. The representation is quite independent of how you use it. In fact, the representation can change on the fly while people are in the throes of using it. So you have this interesting thing that in some object-oriented languages, the systems programmers can be improving the efficiency of objects that people are actually using in various structures. And the inside and the outsides are so sealed off that there's never any time when one is in danger of having breakage. Now, object-oriented stuff is about 25 years old, so it's just starting to come into vogue now. So I saw in one of the conference things for this conference that it is now the 1990s buzzword, which is really kind of funny, because I made up the term object-oriented in 1967. I did not invent object-oriented programming. I invented some of the languages that are used in it, but it was an idea that goes all the way back to the mid-60s. But this is the paradigm shift that programmers are just now starting to take. You see, you think you're conservative? Take a look at a programmer sometime. Just because they're using fancy technology doesn't mean that they are about as conservative as a person can possibly get. And once they've learned something, they imprint on it like a duck to Konrad Lorenz, and never give it up, no matter how spidery what it is that they're doing. Now, in the next 10 years, we really have a problem, and that is that the pervasive network actually isn't strong enough to deal with objects being sent randomly all over the earth and being done by various people and have any possibility of using them. You want something more biological. For instance, if you take a muscle cell from your shoulder and put it down in your thigh muscle, you don't have to reprogram anything down there in order for that shoulder cell to survive. That shoulder cell, like all the cells in your body, knows what it wants from the environment and is fairly proactive about getting it. And if there is stuff out in the environment it can use to survive, it will. That's why we can build a trillion-cell organism. That's how many cells we have. It's about 1 trillion. Is because each cell spends about 90% of all of its effort looking out for itself and protecting itself from the ravages of the environment around it. So most of us believe that there's going to be a new way of programming, which is called agent-oriented programming, or sometimes called modular control programming, in which what you send is something that is very shiny. In other words, when you send something from A to B, no code has to be written at the other end in order for this object to be used. It knows enough to adapt itself to the environment that it finds there all by itself, and no code has to be written. And this way of doing programming has been around now for about 10 years. Just give you an example of, so these are not new ideas in the sense of research, but these are ideas that are about ready to come out of the research labs and start making an impact. How big is a big program? COBOL, 1 million lines, that's a big one. Arthur Anderson does them all the time. An enormously large OOP program with about the same functionality is only 100,000 lines. There are only a few of these around because most OOP programs are much smaller than that. And what is quite remarkable in the last 10 years of doing these agent-oriented programs is that programs with about the same functionality that have been deployed out in the real world have come to about 10,000 lines. In other words, there are these huge factors of 10 between these paradigms. This is where it starts getting interesting, right? Because Americans are not interested in new ideas just because they're interesting. That is not our culture. Never has been our culture. But here is actually a practical reason for getting interested in that there are factors of 10 differences between these paradigms. Why bust your chops working on one of these 1 million line fragile programs when you can do it in 1/10 the time with 1/10 the resources? Wind up with something that is much easier to validate, much easier to maintain. Now, these used to be hand-waving back in the 70s when we were trying to promote object-oriented programming. And it's only been in the last 5 years or so that very large companies have started to deploy these side by side with some of the older ways of doing things, and real comparisons have been done. Arthur Anderson is a good company to talk to about this because they have done some very large programs in object-oriented style and large ones in agent-oriented style and gotten tremendous results. So these are now field-tested results. Well, so another way of looking at it, you can think of each one of these as a kind of an architecture. And in fact, you can think of each technology as a kind of an architecture. So if you know how to put posts down in the ground and put lintels over them, you can build structures of a certain size, and we still use that technology today for building small things. Greeks used it to build the largest things that they ever built, which are temples. If you want to build something much, much larger, and moreover that lets the light in, you need a different architecture. The Greeks never built a structure with an arch except for some grave structures, and they never could actually see that you could get the graves up above ground, and they'd work there too. So they missed completely out on this architecture, and it's quite remarkable that the amount of stone in a Gothic cathedral like Notre Dame is very similar to the amount of stone in a structure like the Parthenon. Seems incredible, but the Gothic cathedral is mostly air because the stresses have been balanced out and there's plenty of room for putting windows in. When you go to a completely new way of doing things that Buckminster Fuller called tensegrity, which means using things you can pull on as well as push, you wind up with things like the geodesic dome, which is quite easy to build a geodesic dome that would fit over all of the Gothic cathedrals that we have ever built on this earth. So each of these architectures is a qualitative difference in approach. And for companies, it's the qualitative difference that gives you the leverage. Now, of course, this is risky. I remember when I first did the overlapping window interface at Xerox, I showed this to a Xerox executive, and this was 1971 or something like that. And wound up the demo with a flourish, and I said to him, and what's more, what's even better about this is that this stuff only has a 20% chance of success. I'm taking risk just like you asked us to. And he looked at me right square in the eye and he said, boy, that's great, but just make sure it works. So he wasn't interested in the romance of it. And like most executives, he wanted us to be in the 20%, 100% of the time. Right? That isn't the way you do it. The best lifetime batting average of any baseball player is Ty Cobb's. It was .367. That meant about 2 out of every 3 times he went up to the plate, he made out. And so research requires actually having some outs as well as having some hits. Now, what's the key to all this stuff? Key is not to get embroiled with just function. If you ask somebody for a screwdriver and they give you this, you get very angry at them. They'd say, why? This is the functional part of a screwdriver. And you'd say, no. I need a user interface because it's the function plus a user interface that gives me the tool. Now, when I made this slide, it forced me to look at a screwdriver in a new way. And when I looked at it, I thought, boy, this is a terrible way of designing a screwdriver. Just think of it. The mechanical advantage on the screwdriver is the ratio of the diameter of the handle to the diameter of the shaft. It's not big. The best way to grab the screwdriver is like this, but then it will slide off the screw. And if I grab it on the top, the way you grab screwdrivers, I don't get very much purchase on it. So I looked at this and I thought, God, that is a terrible design for a screwdriver. That is the MS-DOS of screwdriver designs. Now, the screwdriver, my hobby is organ building, and I have one of the great old books of organ building that goes back to before the French Revolution. And it has pictures in there of the tools they used, and included in there are screwdrivers that look just like the screwdrivers we have today. So this is a design that goes back more than 200 years, and it's terrible. It doesn't fit to the human being. So what if we wanted to fit it to the human being? Well, we want a diameter as large as we possibly could get for maximum mechanical advantage. We need to grab it from the top, and we need maximum friction. So what should it look like? It should look like a ball. Has anybody ever seen a screwdriver that looked like a ball? Yeah. 5 or so years ago, somebody looked at the screwdriver the same way I did and said, boy, that's a terrible design. Maybe it's the COBOL of screwdrivers, the design. But if you think about it, if you want to fit to the human, you actually have to look at the human. So if we want to do user interface with primates, we are a primate, then you have to go with whatever is going on in the primate's mind, and that is not easy, because most of our models of the way the human mind works are not are made up out of common sense theories that are in fact wrong. I'll give you an example of that. So here's an upside down face, and see if you can look at this picture for a minute and then see if you can see anything wrong with his face. Yeah, what is it? The mouth's upside down? Okay, see anything else? Okay, ears? No. How about eyes? No fear of turning your heads to the side. Okay, so let's pretend we're in school. School is a place that treats knowledge as a fluid that can be dispensed from the full teacher vessel to the empty student vessel, drop by drop. And it's usually done by encoding the knowledge into facts in English sentences. So let me give you a fact about this picture. What we've done is we've taken a picture of a young girl, extracted her eyes and mouth, turned them upside down, put them back into the picture, and then turned the entire picture upside down. Okay? Is that fair? Okay, so having said that, you should be quite prepared for what it looks like right side up. I'm going to turn this back because I've discovered nobody will listen to me when it's on the other way. Okay, so what happened there? I gave you exactly the same information twice, once in the terms of a sentence. It went in through the ears, it went over to the left side of your brain, got evaluated as a proposition. You had an okay reaction to it. And then I showed it to you as an image. It went to the back of your brain over the right-hand side of your brain and got an emotional reaction out of you. This is why McDonald's does not run print ads saying, if you eat a McDonald's hamburger, you'll become a better-looking person. Because in English, it's absurd. But if they show a picture of really good-looking people eating McDonald's hamburgers, then you'll make a different inference because it goes to a different part of your mind. In other words, we are multiply minded. We have different ways of dealing with the world, and they're not in sync with each other. And in fact, we have a special part in our mentality that thinks things are more true if they rhyme. So if I were to say to you, a Big Mac and fries will slender your thighs. Sound a little more convincing? And if you think about it, you can imagine why truth and rhyme go together. If you think back over the several 100,000 years of how we've passed our culture down to each other, that the truths of the culture were passed down in rhythmic schemes for memory, and the association with truth is something that advertisers still use today when they make up slogans. It's something that we're entirely unconscious of, and because our mind isn't a seamless fabric, we can get tricked very, very easily. So, just very quickly, Piaget said we have 3 stages of intellectual development, going from a body-centered stage where an object is to grab it, visually centered, the kid thinks there's more water in the tall glass, and symbolically centered where the kid says, oh, there can't be more water. Brunner, who was an American psychologist, took a kid who said there's more water in the tall glass and immediately put a cardboard in front of it, and the child changed his mind. He said, but there can't be. And Brunner removed the cardboard, and the kid said, no, look, there's more water in the tall glass. And Brunner put the cardboard back, and the kid changed his mind again. So if you have any 6-year-olds you'd like to torment, so what Brunner was doing was showing that it's not stages, as Piaget thought, but actually parallel mental activities. In fact, I was just talking to Brunner on the phone a couple of days ago, talking about how well this model has stood up over the last 30 years or so. That in a very simplistic terms, we have at least 3 quite separate ways of dealing with the world that you can think of as separate mentalities. A body-centered way, a visually centered way, and a symbolically centered way. They can be appealed to differently, they have different logics, they have different ways of remembering the world, and you can use them for designing ways of communicating with computers. So if we have a body-centered way of knowing the world, in fact, this is what orients us in the world, we need, when we're communicating with a computer, to have a way of sticking our arm into it. The mouse is one of the simplest ways of doing that. It gives us a kinesthetic relationship. We need something to relate to. So icons are a wonderful way of being stand-ins both for symbolic things and for real objects in the world. Now here are 2. In fact, let me ask the audience here. How many people flip channels on television? We have cable television here, I noticed. So whenever you have cable, you flip. It's okay, we're not going to take a record of this. So a bunch of people do. How many people have ever flipped in the middle of a movie that they hadn't seen for like 20 years? Okay. How long did it take you to recognize that movie that you hadn't seen for 20 years? A couple of seconds. Think about what that means. 20 years ago, you saw this movie, probably with somebody that you were in love with or something. So you were really paying more attention to them than the movie. You didn't know you were going to be tested on that movie. 20 years later, you pop into the middle of it without any preparation, and in 60 frames, you have recognized that you saw that movie before. Now, let's test it out. How many people have had that happen to them? Let's raise their hands so we can see. Okay. How many people knew what was going to happen next? Okay, that's just about right. About half the people know what's going to happen next. Think of what that means over the context of your entire life. Your visual mentality is set up to memorize every scene you have ever seen. And you can imagine why, if you think back over the last couple of 100,000 years. And so appealing to the iconic is something that is almost a no-brainer, even though it's taken many years to do it. And the other thing that's interesting is the iconic mentality can keep track of 100 different things at once. And if we had 100 images of animals, you could find the elephant 4 times faster if it were a picture than if it were a word. That search is done by a different part of your brain than the search for a word. And then you need a symbolic environment, which we called small talk, an object-oriented environment, to tie them all together. And you wind up with something like this, which is the first interface that looked like a Macintosh. So this style of interface, I'm not here selling Macintosh computers. This style of interface, which is now spreading to the IBM PC, is one that was actually designed from a model of the way the human mind works, and its fittedness to people is what has made it go out into the world and be successful. We're going to have to do the same thing when we go and think about agents. Now here's the screwdriver diagram for agents. It's not function, but functionality. It's not a handle, but the agent has to have language and context. What does context mean? Well, an agent for Unix is one of these operating systems that graduate students love that has 500 commands that you have to memorize. Berkeley did a nice agent for Unix, and a user, you could type to it in English, anything that remotely had to do with dealing with computers, this interface could translate and carry out a Unix command to do it. So one day, about 5 years ago, somebody typed to it, "I just ran out of file space, I need some more." Those words. And 20 seconds later, the agent came back and said, "Okay, now you have plenty of file space." Later on that afternoon, the poor user discovered that it had deleted about 1/3 of his files. Now think about that. That's a high score for an artificial intelligence, right? The user wanted more of something. The agent had to figure out it meant less of something. They had to find out how to do that and went and did it. Now this story would not have a happy ending if this were on an IBM PC or a Macintosh, right? Because those files would be gone forever. In this case, though, there was an undelete in the file. This file system for this particular system did not throw away files when you said delete. It just marked them for being archived in a particular way. And so that user, when he discovered his files were gone, just said undelete and they came back. This is what I mean by context. Artificial intelligences can be very, very smart strategically, but they don't live in the same world that we live in, and we have to put them there. And so when you combine the three together, you get something that will function as an agent. And one of the things that agents have to do is to track our goals in some way. They have to stay with us. They have to watch what we're doing and try and understand what it is we're trying to do. And I looked for a way of illustrating this, and I will try and skip to it here. If you just bear with me. This is kind of this is an agent that was done at MIT that I think illustrates what all agents have to do pretty well. So what we have here is a flute player, and the computer is going to play the harpsichord. The computer can hear what the flute player is playing. real people make errors. So we want the system to be able to track what we're doing even though we're not perfect, even at the things we said we were going to try to do. Now you can imagine the poor computer saying, what is this guy trying to do? But the point is, in the next 10 years, that's what we want it to say. What is this person trying to do, and how can I help? So in the next 10 years, the apple cart is going to be overturned again. We're going to go from the second revolution, which we're now midway through. Most large companies are just struggling to acclimate this new technology. And this third revolution, which is going to be a much larger one than the desktop revolution, is going to be in full swing. I pointed out to Apple that we could be incredibly rich by 1995 because we have the best second revolution technology, and we could be out of business in 1997 because there's going to be a complete switch over. Just like Digital Equipment Corporation was in great shape just a few years ago, and now it's struggling like mad. Why? Well, it just didn't move with the paradigms. So these kinds of things are really scary because, again, it's like a thunderstorm. Now, we can anticipate a little bit. We don't know when the tornado is going to hit, but we can certainly build storm cellars. We can decide, we can be proactive about the kinds of things that are going to happen to us. We can start getting interested in networks. We can start asking questions about what are the kinds of goals that we're trying to do in this company, and how can we build agents that will help spread those goals around and help amplify people. But still, it's pretty scary. Sometimes when companies get scared, they hire consultants. It's a good idea. But consultants are like a person who knows 100 ways to make love but doesn't have a girlfriend. They can advise, but it's the people who are actually within the environment that can do the best if they can find a way of getting outside. The reason the consultants work is because the consultants come in from the outside. They have a different perspective, but they're weak in being able to tell you exactly what you should do and how you should do it. If you can get outside the current perspective that you're in, take another point of view, and realize that point of view is worth 80 IQ points. Right? We're not any smarter than we were a couple 100,000 years ago. Imagine a person with a 250 IQ in 10,000 BC. Or Leonardo in the early 1500s with maybe a 250 IQ. He still couldn't transcend the century that he was in. Our smarts come from the change in representation systems that our culture adopts. So we have to do it ourselves. Point of view is worth 80 IQ points, and it's scary to go to that other point of view. But as in all scary domains, the best weapon we have is the one between our ears, providing it's loaded. Thank you. Thanks. Now I have some time for questions, and there are actually some microphones around, I think. I'm not sure I see them, but there are microphones in the aisles and in the balcony, so if you have any questions about either my major or minor arguments, I'd be glad to entertain them. Do you believe everything I said?
I had a question.
Yeah.
How do you personally make the jump from the vision you're showing to the next jump after that?
Well, actually, not so well. Not so well. One of the things I've become very aware of is how much of my mind is in paradigm 2. I brought the Paradigm 3 ideas to Apple when I came, because we could see Paradigm 3 starting to happen in the late 70s. As soon as we got very well networked up at Park and we realized that the Windows and icons interface was not going to survive pervasive networking, we realized that there was another way, and people had thought about this way, and this notion of agents goes all the way back to the late 50s. It was one of the original dreams of John McCarthy, who was one of the founders of artificial intelligence and so forth. So it's not an old, it's not an idea that was startlingly new, but one of the things that I've realized in the last couple of years is that I am so much more comfortable. It's partly because as a musician, I'd much rather play in the band than be a conductor. As I just, I like to grab onto things, and so my natural bent is to be a tool type user. And so even though I can see philosophically what's demanded by this Paradigm 3, and in a way I'm kind of trapped by the stuff that I helped invent. I've not had particularly good ideas in Paradigm 3, except pointing out what it's likely to be like and stuff. But I mean, fundamental technical ideas of solving some of the problems are being done by other people. And it's a very interesting experience to be a soothsayer and inventor of technologies, and to realize that you're in a different world than the one that's going to happen. Fortunately, I like to play music, so I have my retirement well planned. But you see what I'm saying? I mean, this stuff, the toughest thing I think is particularly for managers who tend to be embedded in one particular way of thinking, or a collection of ways of thinking, to be tolerant of, to be able to see that there are other ways of thinking, and to be tolerant of the people who are doing those. That was the biggest problem at Xerox, was that Xerox turned out to be very intolerant of things that weren't like copiers after all. And so when we gave them the Macintosh style way of doing things in 1975, they literally could not see what it was. They just could not see it. And we didn't give it to them as an idea. We had 500 Macintosh-like machines connected to Ethernet networks with 6 or 7 page-a-second laser printers in 1975, and they still couldn't see what it was. So that, to me, is an example of what the paradigm shift problem is all about. And I think for quote-unquote older people, or people who are very efficient and thinking one way, you just have to realize that that isn't the only way to think. And so I think that way of doing things, I think that the people who are coming into a new set of ideas will have enough freedom to develop them. But it's tough. That's why so many new products have had to go to different companies than the companies that paid for their invention, because innovation is distressingly easy to schedule. You just rub money and smart people together, but incredibly difficult to recognize, because by its very nature, something that's innovative is something that you haven't seen before. And when you haven't seen before, the tendency is to reject it or not understand it. Yes?
On your computer, you had a cardboard model.
Uh-huh. Well, it had a pen stuck in the side. And it was based very much on the pen-based system that I showed from RAND Corporation. However, anybody who's ever used one of those systems, and very few people have, even the people who are developing pen-based systems today, have ever used a good one. Once you've used a really good one, you realize that you still need something in order to do volumes of text. Now, for years, in the late 60s, I tried to get people interested in stenotype, where you can go 180 words a minute. It's like a court reporter does. And I just can't get people interested in learning that thing. But there needs to be something. The fastest you can go on a pen writing system is maybe 15 to 20 words a minute. That's not fast enough for doing all of the things that you're going to need to do. Although the second version, I mean the classier versions of the Dynabook that I did showed the keyboard displayed on the display when you need it, and the display was touch sensitive. Okay, that was more of the vision, and something like that will probably be more true than having a discrete keys. Yes?
Why don't we get our educational system out of paradigm one?
I think they're in paradigm 0, aren't they? I mean, I'm not sure that... Well, I think the major... It's something I've been very interested in, and actually have done some work with the Indianapolis Children's Museum and so forth. And I think the major thing on it is that the values that the kid brings into any kind of learning situation are the values the kid gets at home. And I think the value space is more important than any kind of technology that can be rigged up. I've worked with children and computers for 22 years, and I've never been in a successful school situation that didn't have very strong parental support. That is the hardest thing to do. You know, saying that the technology is not a Band-Aid or a magic ointment. It's actually an amplifier or something. It's like if you wanted your kid to become a musician, one of the things you could do is buy a piano or get a piano put in a classroom. But if there's not a value system about music, musicians will tell you the music isn't in the piano, right? If it were, we'd have to let it vote. So the musical impulse is inside of people, and the technology is there to amplify it. And I think that model works very well for computers in schools. So the really hard thing about computers in education is that you have to fix the problems of education without worrying about the technology. We've already got a great technology called BOOK, Basic Organization of Knowledge. Think about that. Solid state, 2.5 megabytes, costs about $3 a megabyte, a couple of 100 million titles and stuff. And we've got technology up the gazoo, and we always have had. What we need is actually some understanding of the way people's minds work so we can set up environments that are not painful. There's no reason why learning should be painful. And we have to have some understanding of what it means to amplify those human impulses with technology. Then I think it's fairly easy. And there are various examples of isolated schools in the country that have no special budget, but just have, for instance, a principal who actually understands how to educate. And the stuff happens. The principal gets the parents involved, realizing it's a sociological process, not just... See, once you get away from this transfer of knowledge fluid, right? This is the factory model of education. It's so wrong. If it were that easy, we'd have no educational problems because we could set it up as something like an industrial process. And that's basically the way certain companies have approached user interface, you know, where the idea is that this is an industrial process and we'll train people in order to use the user interface of this computer. The other way of looking at it is people have all of these human dimensions, and they have an interest in environments and exploring environments and so forth, and you can get them to learn this stuff painlessly while they're using it. And I think that approach works a lot better, but as in all things that are not lockstep, fascist-type control from above, you have to set up an environment that's actually well-fitted to the human in order for it to work. So it's one of those paradoxes that education is a simple problem with a very complicated solution, because most of us don't really want to go through what you have to go through to do it any more than most parents really want their kids. You know, if parents sat down and thought about it for more than 2 seconds, they would not stick their kids in front of the television, even before something like the Gulf crisis. I grew up during World War II in Australia, where we actually had air raids and an occasional Japanese suicide sub. And I had no trauma from the war because my parents told me about the war on a need-to-know basis, which was very, very tiny for a 3-year-old, 4-year-old that I was back then. They listened to the radio after I went to bed, I realize now, and stuff. And so I had no trauma. You know, there's no way a 3 or 4-year-old can handle something like that. So why the heck let 3 and 4-year-olds watch unrestricted television? And once you realize that that is a crime against humanity to do that, then think of all the other things that they were watching before the Gulf crisis. Television has no secrets, and childhood is all about that there's a difference between children and adults. So You know, turning off the television is the first value judgment that any parent could make to help their child learn. Most parents won't take the effort to do that and take the consequence of what it means to turn the television off. That's why I say most Americans actually don't care about education. They want it to be a process done by somebody else, but they don't want to take the responsibility for it. It's a shame, but it sure is the way it is. I saw another hand. So, yeah.
Given everything you said today, where do you see mainframe computers fitting in long term?
Well, I think that there will always be, when you have networks, you always have servers. And I think, to me, what a server is a piece of computing hardware that is designed to maximize certain kinds of processes that are not easy to distribute. I can't imagine anything like a 3090 continuing on, but of course they will. I mean, the customers have to stop buying these things before they go away, and the customers aren't sophisticated enough yet to figure it out. But I think that just as there will always be a COBOL, there will always be things like the 3090. But I think that what we'll start seeing more and more of are special purpose servers. And one of the places where you can beat the heck out of a mainframe is in doing information retrieval. Even today, it's possible to buy massively parallel computing hardware for like $1 million, like a connection machine from Thinking Machines, that has 64,000 processors and can not only do conventional information retrieval tasks much faster, but can do information retrieval tasks that are not conceivable on any kind of stream processing system. And I think we want to think very, very much about what the server environment actually means when we put networks in, and to realize that every time we have to, now the question is, what do we send back and forth? Every time we send things like characters back and forth, we lose. Every time we can send something like an object back and forth, we win. The problem with things like characters and simple raw data is that we have to have very complicated protocols for dealing with them at either end, and what we really want is finesse solutions. So just an example of a nice finesse solution is, boy, when you have a laser printer, one of the things you could do is try and make a protocol for it, right? And all of a sudden you start thinking about all the different kinds of page layouts, right? I mean, this is the way people do standards. Let's see, all the different things people are going to use. You try and enumerate them, and then you make that the standard. That can't work. There are too many degrees of freedom on the page. And so what the Adobe people, Adobe used to be a Xerox PARC lab. And what we did at Xerox PARC was to say, no, we won't do that. We'll let people send programs. We'll just send a program, we'll interpret the program. So we'll know how to execute about 80 operators, and those 80 operators will span the degrees of freedom of the page completely. That's what PostScript is. So the only protocol is that you just send a program, and at the other end there's an information buffer that PostScript tries to build the image from that program. And if you think about the simplicity, the PostScript manual is about 20 pages long. The difference between that and trying to come up with a formatted way of doing things is incredible. This is true for things like CD-ROMs and so forth. Most of the standards that people think about on CD-ROMs and video disks are really stupid because they worry about things like pixels. You know, who knows what display we're going to have 10 years from now. The CD-ROMs are still going to be around. So why should there be a CD-ROM standard that knows anything about the pixelation of current displays? So all of those things, I think, say what we want to do is go to representation independent ways of conveying information, and that's what objects are all about. Getting away from having to know anything about how things are represented or going to be represented, but going to things that are more like saying, I want you to do this and I want you to do that, and the object figures out how to do it. You can change the representation. Yes?
Most of the prototypes that you were showing had a flat LCD screen type display. How do you think virtual reality type
Yeah. Well, we had a chance, you know, virtual reality was actually invented by Ivan Sutherland, who was the guy who invented computer graphics in the early 60s. And when I was at Utah, Ivan Sutherland brought the first head-mounted display system. In fact, the first real-time 3D graphics was done for a head-mounted display that you wore on your head, and the computer knew where you were looking and could change it. So back in the late 60s, we had quite a bit of experience with that, and I think there's quite a bit to be said for it. One of the alternative, there were actually 3 designs for that Dynabook. One was the notebook, one was a head-mounted display, and one was a wristwatch. The wristwatch was for 2010, when you have as many different network connections as you have electric plugs in the wall, so that all you need to carry around with you is something that lets the local computer in the room know it's you. So as you move from one place to another in the physical world, you can imagine your computer agents hopping through the network following you along, right? That's sort of the... I usually don't bother subjecting audiences to that one because it seems... But think about how ubiquitous power outlets are, and even phone outlets are now. So it's just a short step from that to have all the networks in the world be transponding all the time with you. I think the virtual reality stuff, like multimedia, can be a red herring in the sense that both of them are much more concerned with display modalities than they are with content. Both of them, for instance, in order to make virtual reality work, and this is something that we had determined, this is my opinion, but this is something we had determined very strongly in the late 60s, is you absolutely need to have tactile feedback from the environment. Putting yourself in a 3D environment and not being able to touch and feel it is almost impossible. If you ever tried one of these things, it is almost impossible to grab things and know that you're grabbing them and all this. You need tactile feedback. Until they do that, it's just a curiosity. And the same thing, multimedia is a little bit like saying, well, now that we have books, let's put pictures back into them. And we'll put the pictures back in lots of different ways. We'll put sound in. That doesn't count unless there's actually a rhetoric that allows you to organize this stuff in a meaningful way. And that's what really needs to be looked for. You want to, in particular, you want to have it in such a way that multimedia doesn't wind up looking like television. Because television appeals to one part of your mentality and not another. So it'd be distressing if, with all the technology we have on this earth, if we wound up reducing the entire world to the mental state that people had in the Middle Ages. But that is entirely what could happen. It's happening right now. Television is basically electronic stained glass windows. And it has all the pluses and minuses that go along with that. And that is a pre-scientific civilization worldview. It's quite good. We don't have time to really go into it here, but I think it's one of the biggest issues. It's something when I get invited to a multimedia conference, I'm usually on the other side. Not saying make multimedia going away, but I'm saying try and understand it for God's sakes. Just like try and do a user interface, you might as well try and understand how the human mind works a little bit for it. Yes?
What about security of information?
Yeah. Well, there's this old joke about locks are to keep out amateurs. So basically you can boil down most security mechanisms to how much work do you want the person to do before they can steal your stuff. And the answer is you can make it you can make fairly inexpensive locks that are an incredible amount of work for somebody to steal your stuff, and that's pretty good. For the last 5 years, I've been trying to convince publishers to publish on an open network, providing we can prove that we can make geometric copying impossible. It's the same thing in the recording industry. They don't care about numeric, arithmetic progression copying. But what they hate about DAT is that you can do it geometrically because you get no noise. So you get a perfect copy, and the copy can make perfect copies, and the copies can make perfect copies, and you don't get any degradation. And so you can geometrically fairly easily overwhelm something without having the degradation in. What they would like is to have something where degradation is introduced so that you can't sell a copy as the real thing. right? And same kinds of things you have to do when you're doing network security. There's so many different kinds of things that have to be done, and all I can say is technically the problems have been fairly well understood for a couple of decades. None of the processors that desktop computers use have any security mechanisms whatsoever built into them, right? So if we wanted to actually get secure and we wanted to extend the address space of the network into our machines, then we'd have to get rid of all of the machines in place of a separate architecture. I think that will happen fairly slowly. But it's likely that when the first intimate computers start happening, which is about 1995, that they will be built with complete hardware level protection in them right from the start, just from what they are and how they have to interact continuously with the network.
One more question.
Yeah, one more question? Having a hard time seeing. Oh, yeah.
Given that institutions and businesses have to stay in business continuously, do you believe that it's possible for a company to leap one of your evolutionary steps, in other words, to go from institutional to intimate without going through the personal computer stage?
Yeah, I don't know. I don't have a good sense of that, and we're probably not going to be able to find out, because we had one chance for that, and that was if Xerox had decided to do the quote-unquote Macintosh in 1975. That technology was actually invented before any desktop technology was. And then we would have had a chance to see what it was. But I think that because this third one that's coming along is so network driven, and we're so lacking in the kinds of servers that it needs, and it's going to take 5 or 8 years to get the networks going, and where artificial intelligence is and everything else, I think that it's actually going to be a real struggle. So I believe that by, say, 1993, we'll start seeing devices that you put in here that are a combination digital cellular phone and things like electronic mail and other kinds. It'll be like these notebook computers but tied into communications. And by 1995, we'll see full function things that have a fair amount of AI, and we'll be retrieving things that the system thinks that will be interesting for you to know. Even today, you can buy, 10 years ago, one of the first agents I did was called Newspeak, and it was a thing that stayed up all night and found you a custom newspaper based on the kinds of projects you were working on and so forth. And this year, 1990, is the first year when you can, there are 2 companies that are offering a product like that. One is called News Edge, and one of them is called First News. One's for the Mac and one's for the IBM PC. And this is a system where you can gradually develop a profile of the kinds of things you're interested in, and it will log into a half a dozen to a dozen different news things continuously for you and present you with about the 100 most interesting things that's discovered for you. So this is a very simple agent, and all of the agents, I think, in the next 3 or 4 years will be retrieval type agents, because that's an area that just isn't being handled by the SQL direct method way of doing things. And then we'll have to see. A person who would be very interesting to invite here is a guy by the name of Dr. Doug Lennett, who is doing a system called Psych. It's the Psych in Encyclopedia. And what this system is an attempt to model human common sense. So he believes that human common sense can be dealt with between 200,000 and 1 million rules. This is a project that's been going on for about 8 years. It's like modeling the human genome. And his belief is that we can't do real agents until we have a model of human goals, that the agent can relate everything that you're doing to some understanding of what humans are trying to do in this world, and that you have to have something like common sense reasoning in order to pull this off. So that project will not mature for another 5 or 6 years, if indeed it ever does, because it is a very hard problem. So I think that's something that can can be tracked. And what I would do as a company right now is to start doing retrieval type agents. For instance, here's one you could do that would be incredibly useful. Right now, most companies have electronic mail, but they just imitate surface mail, right? This is not moving the motion picture camera. So what would it be like to have a mail system that not only retrieves stuff with your name after the word to, but what if it retrieved mail that had your name in it? What if it retrieved mail that was about the kinds of projects that you're working on? What if it retrieved mail that was about projects that were analogous to the kind of projects you work? See, an electronic mail system gives you a database that is essentially a group mind. It's the mind of Lily, if the mail system is at all good. And yet, because we don't think of it as a retrieval system, we're not using it. And that's what agents are all about, is to take enormous pieces of data and just ferret away at it and trying to find relationships that we can't get at directly. So thanks a lot for inviting me, and enjoy the rest of the conference.